I'm Paul Kinlan. I'm a developer advocate on the Chrome team, and I'm working on trying to make the mobile web platform better for developers and trying to educate people on how we think mobile web development should be kind of done, I suppose. I was going to start this off by saying that I think everyone in California is a little bit too cheery, especially because of the sunny weather and everything else. So I decided to bring all the wet weather with me from London, just so everyone kind of experiences what it feels like to be me. So I suppose the first question everyone has, why mobile web UX at a developer conference, and why someone like me is talking about mobile web UX? Well, I always used to have this impression of, is anyone actually a UX designer or an interaction designer? Okay, I'll be careful. I always used to think kind of UX or interaction design was for people who wore turtleneck sweaters and berets. But it actually turned out that UX is like critically important for everything that we do when we're building applications. And if you're a developer and you're not skilled in the arts of user experience, like me, what do you do? So it's critically important as well for the mobile context, because I don't need to tell you guys all about this, but we know mobile is big, right? Unit sales are kind of skyrocketing. OK, there's an existing desktop presence out there. But every single one of these devices that gets sold has a really capable mobile browser on there. And if you look at kind of some of the work that the ads team have been doing over the past couple of months, they've been doing research on what people like about mobile, what people think about mobile websites. And pretty much everyone likes a mobile-based experience. They hate desktop experiences on the web. So we know mobile is huge. And if we're developers, how do we deal with this context where we need to define and build for the mobile web? Well, if you look at kind of the way mobile native is going, they're kind of really pushing forwards on what it means to be a native developer and a native kind of UX or native experiences. And they're trying to push forward these kind of different interaction styles. So we have obviously voice interaction. That's a big thing on native platforms now, whether it's Google Now or Siri and these types of things. We also have kind of card-based interfaces and gestures and all these really things, all these things that didn't really exist maybe 1-2 years ago. And if you compare that to the web, we are actually doing pretty well on the web at the moment, in the sense of we are starting to get some great mobile-based experiences out there. We've got Forecast, the BBC, Yahoo. Everyone is building these kind of, everyone who knows and gets that mobile is critical is starting to build mobile-based experiences. But they're not as kind of, they don't take advantage of as much of the kind of the hardware capabilities and interaction patterns that native applications are starting to do. So my talk was going to be about how we could bridge that gap. Like how we could start to use voice interactions, how we could start to use swipe gestures and card-based interfaces. But I looked at like the top 1,000 sites originally, and I was trying to assess like what the common patterns are, what the mobileness of the sites are. And it was actually really startling. We found some really kind of interesting things where 53% of sites still had a desktop experience. And these are the top 1,000 sites, right? This is like the head of the mobile web is still desktop, right? There's a couple of really great examples, Wikipedia and Google, Yahoo, and a bunch of others that get mobile. But everyone else in the mobile web is kind of sucks, right? They don't actually seem to think that the mobile web is actually important. And this desktop experience is actually pretty bad, because basically the way the browser works is it goes, well, we know you've got a desktop web. The web is for desktops at the moment, so we're going to have to scale everything down to fit on a mobile device. And if you look at some of the stats where, from the ads team, and I'll try and share a link later on, where users basically 76% of users prefer optimized mobile experiences. This was a survey of 1,000 users at the time. And no one is really catering for that at all on the mobile web. We also find that 25% of sites, even regardless of whether they were mobile optimized or not, their content didn't fit in the mobile viewport. And this is an example of a site where basically you could scroll around the site. You couldn't zoom out from that view. It was terrible. You can't zoom out. You have to pan around the user interface just to read some text. It's not a great user experience. And it's quite common in the top 1,000 sites. And we found that a whole bunch of developers, I think it was actually 65% of users, sorry, hated the fact that they have to scroll around the content to actually find the piece of information that they want to find on the site. And then we found that 83% of sites had hard-to-touch areas on the screen. Now, quite a lot of these sites were just like maybe 1 or 2 little buttons were kind of quite small. But then you get sites like Hacker News, which I know a lot of people read and love, and I absolutely love it as well. But it's completely not optimized for the mobile experience. And then when you actually try and click on a link, the browser has a really hard time trying to figure out what you actually meant to click on. This is actually a really hard problem to solve at the moment, well, on a desktop type of experience. But when you build in mobile experiences, it gets a little bit easier. And this is my blog from ages ago. It's horrible, and as you can see, I'm not a graphics designer or an interaction designer or anything, but basically, of the top 1,000 sites, 60% of them had readability issues. And this actually comes from the fact that if you're not developing a desktop site and the site has to, or not developing a mobile site and the site has to get squished down onto the mobile device, without zooming in, you have a real hard time actually reading the text. And if you see from this screenshot, actually what Chrome's tried to do is try to be clever and actually boost the font size as well, using the text auto size that Greg talked about earlier on. And I'm going to kind of briefly talk about that later on. But basically, text is not readable on the mobile web at the moment, it seems. And 10% of sites in the top 1,000 sites still used plugins. Plugins that don't work on the mobile web. Flash, Java Applet, Silverlight, Unity 3D, all these things where we've been building kind of rich internet applications. And they've been able to do some great stuff for us. But people are still actually have this deployed on the modern mobile web. So actually, this is my first ever kind of mini product announcement. We're trying to build a tool that helps you identify and understand the problems that you would have as a web developer. And this tool is kind of focused towards more of the developers who are not naturally interaction designers, just to help you identify all those issues that we talked about before. So I know Brian mentioned PageSpeed Insights a couple of minutes ago, where it analyzed your network performance of your site in the context of mobile. Well, we're extending this further today, and it's in the test version at the moment. You're the first guys to actually see this. But we're extending PageSpeed Insights to also do user experience analysis. And we're trying to get the fundamentals correct. We're not trying to say, hey, your navigation is kind of busted, your off-screen menus and all these types of things don't work. We're trying to make sure that you actually get the fundamentals correct. And I'm going to go through a quick demo of this in a minute, but basically this tool finds or loads your site in a mobile context and then analyzes it to check for the viewport content size, whether the text is actually readable, whether the links and buttons and other areas are clickable, and it identifies the uses of legacy plugins. Now, this is very kind of early stage, and we really, really, really want your feedback on this tool, whether you think some of the insights are a little bit too harsh or critical, and other types of things that you as a kind of developers can understand, which like features that we could assess programmatically by just analyzing the page. So I'm going to give you a quick demo. I will say, if you bump on UX equals 1 at the end of PageSpeed Insights, you'll be able to go and test this today on your own sites. I'm just going to go and analyze a site which I know is terrible and fails every single URL or every single test. It's actually my site. So I was actually looking for sites to go, and I was like, I'll try my old site from like 2010. Yeah, and it failed everything. It was terrible. But anyway, as you can see here, we've got the kind of the mobile site. This is the rendered view from a headless WebKit. It's got all the speed criteria that Brian talked about before to help you build better mobile network performance. But it's also got this whole area for user experience. And what it tries to do is say, hey, we've rendered the page, we've looked at what the content looks like, and we're going to tell you the areas where we think you should improve. And if you've got a purely desktop experience, quite often it tells you you need to improve everything. But if you've got a mobile-based experience, the number of criteria and checks that it kind of fails on gets a lot smaller. The first is legible text. This is kind of cool. So it basically identifies every single piece of text on the web page. I'll just zoom in a little bit, which doesn't render clearly, doesn't meet the minimum kind of, say, 12-point style font size. Now, this is kind of cool. So I've got a whole lot of things. I used to work for Switch Media, so that was the company I used to work at. Let's have a look. My dad's cycling blog. OK, so you can click on a link, and it highlights it inside the user interface exactly where the identified problem is. This is really cool, because if you're trying to find different areas of the text on your page which have got problems, then you can actually kind of identify that pretty quickly. The really nice thing, and it's kind of, I think it's there in the API, but there's an API backend to this, which you can actually programmatically run through your own workflow tools, which you could then use against your site, which would analyze UX problems across your site automatically. So it's pretty cool. We can find all these different areas where everything kind of fails. And because it's a desktop site, you can see pretty much everything is a little bit rubbish. And it tells you kind of roughly how tall it is on the screen at that time. So that's legible text. The other thing is touch targets. So we identify all the areas on the page where there's potential for confusion by the browser or the user into what would be clicked, essentially. So in many cases, obviously, it's links, and it's links inside text, for instance. But it's also input elements, form inputs, everything that is basically has a click event, which you can listen to. It will identify, look at, and inspect to see whether it's correctly sized. So as you can see here, the search box on this page is it's too small. It's actually, I don't know whether there was a, oh. There we go, do it again. It's actually identified the fact that it's, and this is why it's beta at the moment. So we look at this radio box. It's 714 micrometers on a typical device. I don't know what a web developer is going to do with that, but all we know is it's really small. But we've got all these other areas here where we're trying to identify all these kind of potential touch targets which could be misclicked. But that's not all. There's also this area here at the bottom which identifies targets which actually need additional spacing, because the way that the browsers work is they try and disambiguate the clicks and the areas that where the browser or the user is clicking on the page. And if there are two elements which are kind of pretty close or potentially overlapping, then that creates the potential for confusion for users. And one of the things that we're doing here is we're trying to identify the tap targets which would potentially be too close and overlap and actually provide potentially the wrong action for the user. And then there's some of the basic things as well. Size the content for the viewport. As you can see here, like everything is sized incorrectly. But what this is trying to say is that this is the critical area here, that the actual physical size of the page is 1,299 CSS pixels. And if you've ever done any mobile web development before, you'll know that the actual default size of the browser is 980 pixels, or 960 pixels, or no, 980, sorry. What this basically means is if the content busts outside the viewport, it's too big for the viewport, rather than scale it down further, it forces the user to have to pan and scroll around the site. So we're trying to identify areas where, on the page, you've got content on the page which will cause that now, like the page to bust out the side of the mobile device, in theory, at least. And then we have the configure the viewport. Now this is a relatively simple test. If you haven't got a viewport, it'll tell you haven't got a viewport. If you haven't got a viewport and then you just drop one into your site, you're not going to have a good time. So you're going to have to think about actually building a mobile experience, which I'm going to try and talk about for the rest of this talk now. So this is PageSpeed Insights. This is one of the things that we really want you to kind of go out, play with, give us a whole bunch of feedback about whether you think this is like these checks are actually good for you, whether they actually work on your site as well, because we found instances where there's bugs for like tap target menus across the top just don't work very well. But we want as much feedback as possible. And if you go to that page, there's a feedback link right at the bottom. So this talk really is about mobile web UX building blocks, getting the basics right so that we can build really compelling experiences on the top in the future, whether that's with Polymer kind of web components and a whole load of other stuff. We want to get to the point where you don't have to worry about everything that was the PageSpeed tool essentially is checking for. So I've split this into two different sections, display and interactions, and how they relate to the kind of the PageSpeed Insights tool. Display is about kind of how the content is presented on the device, and obviously interaction is about how the user kind of manipulates the screen and manipulates all the content, whether it's a sign-up form, whether it's like a payment button and those types of things. Because if users can't interact with your site, they don't buy things, they can't log in, they can't sign up for your service, and you have a really bad time on mobile. So we look at display, and I'm going to go through this pretty quickly. And I really hate doing this slide, but the most important and critical thing that you can do for building a mobile web experience is make sure that you use a viewport. The viewport defines essentially the size the content should be on that area on the screen. And this is our preferred and recommended configuration, meta viewport or meta name equals viewport content width equals device width, because that essentially allows you to ensure that everything's sized to whether it's 320 pixels on iPhone up to about 380 on a Nexus 4. And it basically means the browser doesn't have to scale the content down from a traditional desktop experience into a more mobile experience. And I think that's a bug in Chrome at the top. We'll get from there. And actually, the reason why I want to show you why this is actually kind of critical is that I've taken the way that the browser renders content on a desktop content on a mobile device and compared it to how it's rendered on a viewport configured page. And as you can see on the right, it's probably a little bit hard for you guys to see, but that's a 12-point font, which means at kind of arm's distance, it looks like a 12-point font on a page, essentially, or a normal piece of paper. If you don't have a viewport, it roughly reads like a 5-point font. Like, it looks like the point where it's nearly kind of unreadable. OK, we have retina-based devices, which let us kind of distinguish the layout of the text a little bit better, but 5 points is really not that readable. Nexus 5 is the same. Everything is roughly a third of the size of what it's actually intended to be. So a 12-point font, in this case, reads like a 4-point font. Nexus 7, obviously, is better, bigger screen, and all those type of things, but it's getting to the point where the text on a default mobile experience or desktop experience on a mobile device is completely unreadable. 7 points is just at the point of being unreadable. And obviously, in Nexus 10 and the kind of the iPads as well, it's a lot less noticeable. Not having a viewport, you get to the point where the text looks like a 9-point font. Kind of what like I told you then was really a lie, because basically browsers try to compensate for the fact that they know that the desktop web is terrible on a mobile device. So in Chrome's case, we use kind of text auto size, and basically what happens is when the page, just as the page loads, an algorithm goes through all the kind of the text nodes and looks to see what text it should resize to make more visible. And on some pages, like my blog before, it's not too bad. The content at the top of the page is made bigger because that's the primary focus. But then you get to sites like this, which is Hacker News, which is the same page as we saw before. There's certain comments which read really well. Like the browser's gone, yeah, this looks important. It's not semantic analysis. It's just kind of some basic heuristic. But then there's other bits, like in the middle here, which you can't see. You can't read the text. You can't read the text here. You can't read the text on the device. You have to zoom in. So the algorithm isn't perfect. And the best way to get around that is to start to design for a mobile web-based experience. Obviously, use a viewport. There are little hacks to kind of get around it, like by making sure your content, I think, is over 100,000 pixels high. It's not even worth going there because that's just one of those things which might change in the future when people kind of get rid of that. But essentially, browsers try to compensate, and when the browser tries to compensate, it kind of starts to ruin your design, essentially. It doesn't represent how you actually intended the user to read your content. And obviously, fit the content to the viewport. There's not actually anything technical that we can say about this. It's just make sure everything is sized correctly and there's no kind of horizontal scrolling. Vertical scrolling's fine, and horizontal scrolling's actually fine by default, but if you have to have the user pan in multiple directions, that's when users actually start to get frustrated. And I'll share the link later on where the ads team have done this analysis to actually show that users don't like it. But the interesting thing is that scrolling varies from platform to platform, and iOS at one point, I think it probably still does, used to have a scroll lock. So if you're kind of moving up in the vertical orientation, you can't scroll left or right at the same time because it's saying, well, you don't want to pan around, you want to just look at the content itself. But we want to get from this situation, away from this situation where you have to actually move around the web like that. I do have a question. Who's got a 24-inch phone? No? OK. That was really heavy, by the way. It was crazy. So I'm not going to tell everyone about this too much. Like media queries, we should be kind of concentrating on like mobile-first design, responsive design as well. Obviously, you can kind of orient, like you can design your site to work better on portrait, on landscape, and a whole load of other stuff. This is one of those areas that's like super critical for web development. You want to be looking at how you actually design your site to be responsive rather than have to do it all on the server. It's best to do it on the client. I'm not going to go into it too much because I'm pretty sure everyone knows about this. The thing I want to say is about how you decide the breakpoints in your site. And Paul Lewis has been working on a redesign for HTML5 Rocks, which is our documentation resource. And the old site looks cool. The new site looks cool. But what happened is on the original site on the left, we basically tried to size for devices. So every other week, we would look at kind of Google Analytics to understand the different types of devices that were available or kind of accessing our content, and whether it was a tablet device or whether it was a mobile device. And then we would say, well, this kind of looks like a tablet size. We'll push them to the tablet user interface. Looks like a desktop. We'll push them to the desktop interface. And what we found, rather than actually concentrating on the devices, whether it's iPhone, Android, or whatever, and the device form factors, we literally just tried to say that, well, actually, we'll scale the content out left and right, and then we'll decide where the breakpoints are based off how the content looks at that individual time. So basically, we're saying you size the breakpoints to the content rather than the actual devices, which a lot of people do, and we were just as guilty as doing that as everyone else. The reason why we say this is because we went from 17 media queries. Our media queries for the HTML5 Rock site, if you go and check it now, is just an absolute mess. And it's really hard to maintain, and you get into this weird situation when it doesn't actually, we've got like weird overlapping media queries. It doesn't actually kind of know what interface it's supposed to present to users at any one time. So we went from 17 media queries down to something which is a lot more manageable for us, 4. And we have nice looking kind of content on desktop, mobile, and tablet as well. One of the other areas that we're kind of talking about is font readability. And I looked at the human interface guidelines. And this is the whole kind of the PageSpeed Insights test, the legibility test. And the human interface guidelines from Apple are really cool because they say if users can't read your text or the word in your app, it doesn't matter how beautiful your typography is. And this kind of it's ultimately applicable regardless of whether you're designing paper-based content or kind of web-based content or content inside apps. And our guidelines and the way that the PageSpeed Insights tool works is it tries to say, you should be sizing your text to be readable kind of at arm's distance, which from like numerous studies, whether it's Apple, Microsoft, or Google as well, like 12-point fonts is the minimum that you want to suggest, which is roughly 1M or roughly 16 pixels in height. But the interesting thing as well is that we're actually trying to say that what you should be doing as well is like consider where the user actually uses your content. They might be out in the cab or walking down the street, and you want to make sure that there's a decent amount of contrast between the foreground text color and the background color as well. We don't actually analyze that yet, and we're trying to work out whether like these type of things are important or not for you as a mobile web developer when you're checking your site. And obviously things like maintain decent line heights so that the text is readable and you don't have to get confused between the lines. Yeah, so font readability is kind of critical, and that's one of the things that we look for when we're doing the PageSpeed Insights tool. We also want to kind of, we don't check for this, but we're trying to get people to limit the use of web fonts at the moment, especially on a mobile device, because if the web font doesn't exist either in the cache or on the user's device, then essentially, especially on WebKit-based browsers and Blink-based browsers, you're left waiting around for the content to actually appear because the font doesn't exist, so it's not actually kind of, it doesn't actually appear on the site at the time. And our guidance at the moment, and this might change once browser implementations change essentially, is just to use it for headings. But critical content, like the text, like if it's HTML5 rocks, the article body content would just be a normal system-wide font essentially. The interesting thing to say is Paul Irish had a post on Google Plus talking about the flash of unstyled text, essentially, where we're talking about the different implementations between browsers. So obviously WebKit and Blink are kind of quite consistent because they're both off the same heritage, where the content doesn't appear, whereas Firefox is a little bit different. I believe the text appears as a system font, essentially, until the actual web font is downloaded. And we're looking for kind of your feedback about what you think is the most important thing, because we want to make sure that if we're going to be if we want to be good web citizens and everyone wants to get this, we have the same type of implementation across browsers. And it might be at some point that the actual Firefox implementation is the preferred one, but obviously we need a lot of feedback from developers. So go to that post, have a look at kind of the suggestions, and then let Paul and everyone else know how you want to have web fonts presented to the user. I'll tweet this link out because I know it's not exactly visible. So that's display. I want to talk about interactions, and I'm going to be really quick. Click disambiguation is really important because essentially the user, like this is Chrome, when the user clicks on an area inside Chrome and it doesn't know exactly where the user is, it presents a magnifying glass. It's a great accessibility feature. The problem is, though, that it actually presents a challenge to users because there's an extra step before they actually do anything. So we want you as a developer to try and get away from that. And I'm going to kind of roughly go through the process for this, how this actual disambiguation works. Essentially, the user clicks on the screen, it's roughly a 48-pixel bounding box, works out where the click is, adds an area, kind of like an error buffer around the side, finds all the targets inside the bounding box, the potential candidates for what the user actually meant to click, scores each element based on the closeness to the original touch. In this case, it finds one, that's the closest element. And then it basically compares the scores across all the rest of the elements, and then tries to find the elements where the distance between the original touch is roughly about half the distance to the closest element. It's relatively complex. The code, if you're interested, in Chrome is over there. The simplest answer is just to use sensible padding. Like you're building a site, just don't be stupid. Like space elements out pretty quickly, which leads us on to this whole idea about what are kind of interesting tap targets. All the different types of human interface guidelines talk about things which aren't native to the web. Points obviously for fonts, but dips on Android, like what's a dip? Like Microsoft is 9 millimeters. I don't know how that really applies to the web. But roughly, if you take one CSS pixel, the standard reference, to be 96th of an inch, you can roughly work out that everything is around between 29 and 33 pixels in size. Our recommendation in the tool that we're using at the moment is around 26 pixels, but with a decent amount of padding. We're recommending 8 CSS pixels, or roughly about 2 millimeters worth of padding, and that helps the disambiguator not have to reselect which, or kind of basically pop up. The other interesting thing around this as well is that if you're trying to get data put into your system, interaction, you get used to sign up to your app or your site, you want to have form inputs that are easy to read. and easy to enter data. Labels are the thing. You should always go for this. Basically, the reason why labels are actually important is because, in this case, it's doubling the amount of touch size that is available for the user to actually be able to focus the input element. Now, obviously, you can style your site however you want. But in this case here, like I've got the top element and the bottom element, both are touchable, and both focus the same input box as well. So it's relatively simple. Obviously, it's up to you how you actually decide how it's styled, but it's one nice little thing that I quite like. Who actually likes waiting in the queue? I mean, I'm British, I do. I love waiting in queues. Like, this is me trying to get to Berlin. I patiently waited in this queue for 3 hours without complaining at all to anyone. And then I got to the front, and I apologized for missing my flight. And like, it wasn't me who missed the flight. Anyway, it's kind of like waiting 300 millisecond click delay, right? The 300 millisecond click delay is this thing to help us kind of, like get the user to zoom into the content for a desktop-type display. Now, it slows down interactions. Everyone knows it's horrible. We don't really complain too much. It'd be great if we could kind of remove that from the web. I do have a kind of a question, though, and this is styled off the Google interview questions, which we know are great at hiring candidates. How much time do we waste every day with the 300 millisecond click delay? Has anyone got a guess? Right, I have no idea. Right? That's what everyone says when they get asked these stupid questions. Well, I have no idea. What a stupid question. But actually, I do know for Wikipedia. Right? Wikipedia actually publish all their mobile traffic. They get roughly about 3 billion requests a day on mobile, which is 1,400 requests per second, which is 423 wasted seconds every second just on Wikipedia alone, which roughly equates to 1 year wasted every day just waiting around for your click to complete. So it's pretty cool. Chrome is removing the 300 millisecond click delay, which is great news. Oh. And I'm going to talk about what we're going to do, because it's not going to be for everyone. And it's great for links. I don't know whether this actually came across very well. It looks like the videos aren't playing properly. You click on a link, you don't have to wait 300 milliseconds. But as you saw before, like if it takes 10 seconds to load your page, the 300 millisecond saving that you get is not, you've got bigger fish to fry, essentially, if your network requests are that slow. But it's great for interactions. And Jake Archibald made this video. On the left is the 300 millisecond click delay. On the right, it's 0 millisecond click delay. Everything just feels a lot more responsive. Like you click on a button or a checkbox or a link, or not in this case, a link. You click on anything that has a click handler, it happens straight away. It just feels a lot more natural and reactive. So how do you go about removing the 300 millisecond click delay? It's not killed for everything. The simple answer, and it relates to one of the very first slides, use a viewport. Make sure the width equals device width, but also size the content of the viewport. If we don't have to pan left and right, then we've got a really strong indication of the fact that the user will not have to zoom in to the page. So if we don't have to zoom in, why actually do the double tap to click gesture? Pinch to zoom will still work, but double tap to click, we don't really need. Or use fast click. I know some of the FT Labs guys are here today. If you're not on Chrome, you can use the fast click library to kind of get around some of those interaction problems. Who loves typing on a phone? Yeah, good, because no one loves typing on a phone at all. The goal that we want to try and get developers to is just to minimize the amount of typing that you have to force your users through. Obviously, this is really simple. I hate talking about this slide because it's been around for years. It's just they take advantage of specialized keyboards and mobile devices. Like if it's an email address, say it's type email, you'll get an @sign. If it's like a date or a number, or sorry, if it's a telephone number, say it's a telephone number, and you get a special dial pad. If it's a number, you get a special number pad. If it's a date, you get a special data entry button. Now it doesn't speed up the time to actually complete a form, but it does increase the accuracy. And I did some completely non-scientific tests, so I'm obviously a good authority on this. And some of the tests that I did, where I asked people to enter certain kind of input, like certain kind of data, basically it was like 95% accuracy at the time for the input types, because it was so constrained. Now that's completely unscientific, so don't go about quoting that one, but everyone knows when they see the correct input type, they like it. Also take advantage of autocomplete. The browsers are actually pretty good at this, and if you look at Stack Overflow, everyone seems to hate it. But you want to try and get your users not entering data if it's already stored inside the browser. And the way that you get autocomplete to work is to use kind of names for field labels that are similar, or that are well known, essentially. So if you want to get the first name, F name. If you want to get the surname, L name. Like the email address, obviously name equals email. Those type of things, they just help the user. If it kind of starts to autocomplete, you press it, the form's completed really quickly. And it's zero cost for you as a developer to actually implement. The next is requestAutoComplete. So who's heard of requestAutoComplete? A couple of people, really cool. Basically, the idea behind this is to have a programmatic access to the the form autocomplete. And now this is another video by Jake. It's a really good video, or a demo by Jake. Essentially, you have an API which uses an existing form. You call, you can basically go, I want to check to see if requestAutoComplete exists. If it doesn't, you present the original form. So that people can just go straight through and enter the data in. If it does exist, you can call the requestAutoComplete, which pops up the box that we saw before, lets the user select kind of their data, maybe also if you're in the US, kind of autocomplete the credit card with Google Wallet. And then you can go through and complete the form and submit really quickly. The aim is to kind of really improve the time to submission for form data. If you have to enter this manually, it's like 2 minutes just entering text to kind of get your shipping address and billing address and a whole load of other stuff. And we want to get away from that. So the requestAutoComplete API is there. I'm going to start wrapping up now. Our goal is to get as much feedback at the moment for this tool. So please go out and check the PageSpeed Insights tool. Put UX equals 1 at the end, and you'll get the actual the tools available. And I'd like to thank everyone. I know I've run over a little bit. mobileux.appspot.com is these slides. html5rocks.com/mobile is our mobile documentation entry point. Thank you.